The definition of the limit process is for the integral from a to b of the function f of x dx, it is equal to the limit as n approaches infinity of the summation from 1 to n of fc sub I delta x. I'm going to be showing you how to do this for this equation, this problem, the integral from 1 to 9 of 4 minus x dx. So my first step is going to be finding delta x, and to do that, use the equation b minus a over n, b being 9 and a being 1, so that would be 9 minus 1, all in parentheses, let's just pretend they're in parentheses, divided by n. Alright, actually I'll just put them in. Alright, which simplifies to 8 over n. Now, we have delta x for the rest of this problem, which is 8 over n. So next we're going to be finding c sub I, and that would be a plus I delta x. So in this, our a is 1, so c sub I would be 1 plus I times 8 over n, because 8 over n is delta x, so it would be 8i divided by n. Okay. Now we're going to plug in the c sub I to the equation 4 minus x. And by doing that, we get 4 minus c sub I, which is 1 plus 8i divided by n. So we could simplify that down even further into 3 minus 8i over n. Okay. Now that we have those three steps, we could go into the limit process. So this equation up here, I'm going to move this over a little bit. Alright, so this would be equal to the limit as n approaches infinity of the summation, the limit as n approaches infinity, the summation of as from I to n of fc sub I. So just take this here, fc sub I, times delta x, which is 8 over n. So I'm just gonna put a little times symbol right there. Okay. Now from here on, it's just using properties and simplifying algebra and all that. So from that, we could say that the limit as n approaches infinity of this, from actually before even that, we could move this 8 over n, this delta x, to the front of this summation, but not in front of the limit. Okay? So we'll put that there. That's a property. And after that, we could also split up this 3 minus 8i over n into two summations. So it would be summation I from I to n of 3. 3. And then we could, which is 3 minus another summation of 8i over n. Now we're going to simplify this even further. So what we could find is that this is equal to the limit as n approaches infinity of 8 minus n, 8 over n, I mean, times, since this is a constant, we could multiply it by the upper bound, which is, so this would be 3n. But, yeah, this would be 3n minus, for the second summation, we have to simplify it even further. What we could do is we could drag out this 8 over n to the front of here, so we could just find the summation of from 1 to n of I. So all simplified out, that would be minus 8 over n times n times n plus 1 all over 2. Okay. Now we do some more algebra. We multiply this out in here, and with that, after some simplification, we get 24 minus 32 times n times n plus 1 all over 2. Now once we get there, we could plug in infinity into the ends, and when we plug it in here, it would be, sorry about that, that's not the correct thing there. It would be 32 times n plus 1 over n. And once we plug in infinity to that, we see that this actually just goes to 1. And from there, you'll see that it is just 24 minus 32, which is equal to -8.